In this lesson, we're going to learn how to subtract whole and mixed numbers. In our first example, I have 8 minus 3 1/3. Now, I cannot just do 8 minus 3 and get 5 and then just bring the 1/3 down here because I never actually subtracted 1/3 from anything. So it will never be that simple. I need to start by looking at 8, and I need to rename 8 so that it has a fraction with it. So if I had 8 pizzas, 8 whole pizzas, and I had 3 pizzas and then 1 cut into thirds, the situation would say I have 8 pizzas and I want to eat 3 whole pizzas and then I want to eat 1 slice of a pizza that's been cut into thirds. So in order to see how renaming works, I want you to look at my 8 whole pizzas. And what I can do is take one of these pizzas and turn it into a fraction so that I would have 7 whole pizzas. And then looking at my denominator, I want my pizzas cut into thirds. So if this pizza was cut into thirds, the fraction would look like 3 out of 3 slices. And I know 3/3 is the same as a whole, and 7 and a whole pizza would still mean the same thing as 8. So all I did was rename 8 as 7 and then make a fraction worth 1 whole. Now I can subtract because I have fractions and whole numbers in this problem. And I always do the fractions first. 3/3 minus 1/3 is 2/3. 7 minus 3 is 4. So my answer to 8 minus 3 1/3 is 4 2/3 pizzas. In this next example, I have 12 minus 2 8/9. So if I had 12 full unopened pizzas and I wanted to eat 2 whole pizzas, but I also wanted to eat 8 slices out of 9 slices, I know that I need to make this first number have a fraction with it. So by doing that, I can take away one of my pizzas, and I know that the denominator right now is 9. So they want each pizza to be cut into 9 slices. So now I can look at this fraction as I have 11 whole pizzas still. One of them I have cut into 9 slices, and since none of the slices have been eaten, I have all 9. So 12 can be written as 11 9/9. 9/9 is still 1 whole, and so this value is still equal to 12. Now that I have a fraction, I can subtract across. 9/9 minus 8/9 is 1/9. 11 minus 2 is 9. So 12 minus 2 8/9 is equal to 9 1/9. In these next two examples, I have a whole number minus a fraction. So I'm going to continue using the method I was using and rename 17. So if I take 1 away from 17, it becomes 16. But I also need a fraction that is the same as 1 whole. And because I can only add and subtract fractions with the same denominators, I'm going to look over here and see what denominator they use. They use 12. So when I take away 1 from 17, it became 16. And my fraction is going to use the number 12. And to have it equal a whole, it has to be 12 twelfths. So 16 and 12 twelfths is the same as 17. But now I can actually subtract the fraction. 12 minus 7 is 5 twelfths. 16 minus no whole number is going to be equal to 16. So 17 minus 7 twelfths is 16 5 twelfths. Our next example is a very similar situation. 22 minus 14 twentieths. So since there is no whole number, I'm only going to be subtracting the fraction. So I need to rename 22. If I take away 1 from 22, it becomes 21. And now I need to come up with a fraction that equals a whole, so I'm still having the same value as 22. I look at the denominator they're using, and they're using 20. And in order for this fraction to be a whole, I need to rename it as 21 and 20/20ths. And now that I have two fractions, I can subtract. 20 minus 14 is 6/20ths. 21 minus nothing is 21. And just to continue with always checking for the simplest form, 6 and 20 are even numbers. And I could divide both of them by 2. 6 divided by 2 is 3. 20 divided by 2 is 10. 3 and 2 cannot be simplified any further. So your final answer would be 21 and 3/10. In some situations with subtraction, you won't be able to subtract the numbers. For example, if I only have 1/3, I cannot take away 2/3. But if you look at my whole number, I know that 5 can take away 2. There are two types of ways to solve these problems. The first way would be turn both of your mixed numbers into improper fractions. I know 3 times 5 is 15, and 15 plus 1 is 16. So this is an improper fraction, would be 16/3. 3 times 2 is 6, and 6 plus 2 is 8. So this is an improper fraction, would be 8/3. 16 minus 8 is 8/3. And then in order to give my final answer, this is improper, so I need to turn it back into a mixed number. So 8 divided by 3. 3 can go into 8 2 whole times. 2 times 3 is 6. When I subtract, 8 minus 6 is 2, so my fraction would be 2/3. So 2 and 2/3. So the first way is to make both fractions improper. The second way to solve this problem is similar to what we were doing before with borrowing. So I'm going to rewrite the same problem and show you a different way to solve it. Earlier, we were looking at our whole number and renaming it. So in this situation, if I take 1 away from 5, it becomes 4. And I need to rewrite a fraction that has a whole, and right now our denominator is 3. So I could rewrite 5 as 4 and 3/3. But I have to remember that I also had 1/3 next to the 5. So I'm just going to total together these fractions. And when I rewrite it as a whole thing, it will equal 4 and 4/3. Minus 2 and 2/3. So even though this fraction is improper right here, it's improper because I have a whole and I have the additional fraction that I had already in the problem. Now I can subtract my fractions. 4 minus 2 is going to be 2/3, and 4 minus 2 is going to be 2, and I still end up with the same answer of 2 and 2/3. So if you're going to borrow, you need to make sure that you combine with all fractions next to a whole number. And if you use the improper method, you need to make sure that you turn both mixed numbers improper, and your final answer needs to be turned back into a mixed number. Our next example is 13 and 2/5 minus 6 and 4/5. The first problem I run into is that 2/5 cannot subtract 4/5. So my first strategy could be to turn both of these mixed numbers into improper fractions. So I'm going to start with 5 times 13. So over to the side. 5 times 3 is 15. 5 times 1 is 5, plus 1 is 65. And then I need to add my 2 up here, so this is going to be 67 fifths. 5 times 6 is 30, and 30 plus 4 is 34 fifths. Now I can subtract across. 7 minus 4 is 3, and 6 minus 3 is 3. And the denominator stays 5. Now this is improper, so I need to divide. 33 divided by 5. 5 will go into 33 6 whole times, and 6 times 5 is 30. When I subtract, I have 3 left over out of 5. So my answer is 6 3 fifths. Our second strategy that would also work is borrowing. So I'm going to rewrite the problem, 13 2 fifths minus 6 4 fifths. So if I want to rename 13, I would take 1 away, and 13 would become 12. But then I also need to create a fraction that's worth a whole, and right now the denominator in the problem is 5, so we're going to choose 5. So I can rename this as 12 5 fifths. But it wasn't just 13, it was 13 2 fifths. So I'm going to combine the two fractions right here. So instead of 13 2 fifths, I can name this 12. 5 plus 2 is 7 fifths minus 6 4 fifths. Now I can just subtract my fractions and my whole numbers. 7 minus 4 is 3 fifths. 12 minus 6 is 6. And my answer is still 6 3 fifths. Both strategies will work. I will say that the strategy that has the least number of mistakes would be the improper method. If you are going to borrow, you need to be very careful about combining your whole number fraction with any additional fractions in the mixed number. Now try these 4 practice problems. Use whichever strategy makes the most sense to you, whether it's turning both improper or borrowing and creating a fraction worth 1 whole. Remember to look at the denominators being used in the problem to help you develop a fraction with the denominator. Use estimation to help make sure that your answer is reasonable.